I'm Anil Kumar, and here is another video which will really help you to simplify the solution of questions. The question here is, determine equation of a polynomial from the given set of points on it. So we are given 6 set of points here, x values and y values. All these coordinate points are on a polynomial. We need to find equation of this polynomial. Generally, to answer this question, we use finite difference method, and depending on which finite difference is constant, we know the degree, and then we solve simultaneous equations. And this process, as you know, is very time consuming and it leads to errors also. So what I will do is I will show you the method, and I will also show you ways of solving it in more efficient way, right? That's how I should put it. Okay, so let's begin with first finite difference. If it is constant, it will be degree 1, and that is why I'm writing like this. That is difference, first finite difference. It really means y2 minus y1. 0 minus 10, of course, is minus 10. Now 0 minus 0 is 0. 16 minus 0 is 16. 54 minus 16 is, I'll have to check with calculator. Let's do it. Okay, 54 minus 16 is equals to 38. Don't hesitate to use calculator, right? 120 minus 54. Since this type of question you could get wrong at any stage, and there are too many calculations to be done here, right? So first difference we notice is not constant. That really means that the equation is not linear. Okay, let's see if it is quadratic. That is the second difference. So 0 minus 10 is plus 10. 16 minus 0 is 16. 38 minus 16 is 2 and 2, 22, and this minus this, let me do this, 66 minus 38 is equal to 28. Okay, good, which is also not constant. Okay, that means we have to go further and find the third finite difference. Okay, so let's find the third finite difference. So it could be cubic, correct? It could be cubic. So let's do it. 16 minus 10 is 6. 22 minus 16 is 6. 28 minus 22 is 6. That is constant. Perfect. So this is constant, right? Since it is constant, we know it is a cubic equation. So we know it is cubic. Now the second job is to find the equation. In general, when we say it is a cubic function, then the cubic function is written as f of x equals to ax cubed plus bx squared plus cx plus d, right? So that is the cubic function. 1, 2, 3, 4 unknowns means 4 equations, correct? Then you get your answer. So what you will do at this stage is you will write down 4 equations. You'll say f of 1 is equals to, substitute x as 1. So you get a plus b plus c plus d. And you know f of 1 is 10, so you'll write 10 here. Then you say f of 2, right? f of 2 is 2 cubed, 8, plus 2 squared, 4, right? Plus 2c plus d equals to, f of 2 is 0, you write this as 0, then you say f of 3, right? Good job. 3 is 3 cubed, okay, 27, okay, that's fine, 27a. 3 squared is 9, 9b, 3c, right? For any cubic equation, these coefficients kind of work out to be same, right? f of 3 is also 0 for us, okay, we need fourth equation also. You'll say f of 4 equals to, now plug in 4 cubed is 64. You can use your calculator. 16 is square and 4c plus d equals to, the value is 16. And then the job starts solving these 4 equations simultaneously to get the value of a, b, c and d. And that is, as you know, and you must have realized, is so difficult, right? Now here is the method which really helps you to solve this, right? So we'll just stop there. You can continue, solve, get your answer, then check with my alternate method, right? So that is the beauty. So alternate method, okay, that's great. Now what is my method? First is you should know the relation between leading coefficient and finite difference, right? So leading coefficient A is finite difference. If it is for third finite difference, then that finite difference, which is of order 3, in this case it is 6, divided by 3 factorial, right? 3 factorial is 3 times 2 times 1, and that gives you 6 over 6 as equals to 1. So this is the formula which you can always apply, which I've been, preaching for a long time. So the formula basically to remember here is A equals to whatever finite difference. If it is nth finite difference, then delta that finite difference divided by n factorial, right? And n factorial may be a new term for some students, is the product of n, 1 less than n, right? 1 more less than n. Continue this process till 1, right? So, okay. For example, if n is 5, then it will be 5 times 4 times 3 times 2 times 1. That is what it is. So in this case, it was 3. So 3 times 2 times 1 is 3 factorial, right? So that is how I used it. And that is the constant finite difference. So the beauty here is that we have reduced the number of equations by 3, since now we know that A value is known to us, right? So we know A is 1 for us. Good. So if I substitute A as 1, we can actually solve with these 3 equations, correct? You see that? We could solve it with these 3 equations now, which will reduce your time by at least 25%, if not more. Okay. What else do you observe here? Another great thing which you observe here is the zeros themselves, right? So we have 2 zeros and we have a cubic function. That means what? That means I could write my function in factored form. So factored form is an excellent way of writing cubic equation. We know A times x minus x1, the first zero, x minus x2, the second zero, x minus x3, the third zero. Maximum there could be 3 zeros for a cubic equation. Now fortunately for us, we know A is equals to 1 for us, right? And 2 zeros are known to us. 1 zero is at 2, the other one is at 3. Good. So we could write this function as f of x equals to 1. So I'm not writing 1 here, but I could write the 2 zeros as 2 and 3. Okay, that means I get x minus 2 times x minus 3, and what remains is to find the third zero. Okay, if you find this, you're done, right? That is how it is. Now you need only one thing to find. That means you need to work with just one set of coordinate points. You could use f of 1, which is at 10. So we'll write f of 1, replace x with 1 here. 1 minus 2, 1 minus 3, 1 minus x3, the third root, and that should be equals to 10, right? That should be equals to 10. Perfect. Now from here, we know this, 1 minus 1 is minus 1. Let me write minus 1, okay? And 1 minus 2 is, 3 is minus 2, okay? And this is 1 minus x3, which is equals to 10, right? So that really means that, let me write down here because I'm running out of space. 1 minus x3 is equals to 10 divided by 2, right? Which is 5, okay? And that gives you the solution as x3 is indeed equals to 1 minus 5, which is minus 4. That means the third zero is at minus 4. Great job. So once you get the third zero, you know what the solution should be, right? Now you can write down your function f of x as x3 is known to us, right? So we have x minus 2 times x minus 3 times x minus minus 4. That makes it plus 4. Perfect. So that becomes the solution for us. Do you see that? Isn't that neat? So in this little space, which I always prefer half a page to solve any question, we have the complete solution along with the suggested alternate method or your standard method, right? So what you observe here is that if you blindly solve the question with your standard techniques, you'll end up solving 4 equations, right? If you use some techniques like A, which you can find with ratio of constant finite difference and the factorial of that, you will land with 3 equations, saving 25% of time. And if you investigate further and use the zeros and apply with the factored form, then you can do it in no time. That's the beauty, right? So my suggestion is, whenever you're working with polynomial functions, keep an open mind. Try to solve your question in the best possible way. And please, please, please do not always follow the standard method. Standard method is a guidelines which is probably the last resort. I hope that helps. Thank you. and try some more questions. All the best.